All right, welcome to the Explainer. Ever wonder what's actually running behind the scenes at Google Search or YouTube? Well, you're about to find out. Today, we are breaking down the Google Cloud Platform, or GCP, and looking at how it lets pretty much anyone tap into that same incredible infrastructure for their own projects. So here's how we're going to tackle this. We're going to start right at the foundation. I'm talking the physical cables and data centers that literally span the globe. From there, we'll get into the core choices you have to make, like how to run your code and where to store your data. Then we'll see how GCP is built to handle massive scale. And finally, we'll set up some practical examples to make it all click. Okay, first things first. Before a single line of your code runs in the cloud, it has to run on a physical computer somewhere on Earth. The cloud isn't some mystical thing floating up there. It's a very real network of massive, seriously advanced data centers. GCP's physical footprint is one of the biggest on the planet, and you gotta understand how it's all laid out to really use it well. To organize this whole global operation, Google uses a pretty simple hierarchy. The world is broken up into regions. Think of these as large, independent geographic areas, like US East 1 or Europe West 2. Now, inside each region, you have multiple zones. A zone is basically an isolated data center facility. The whole point is that if one zone goes down, the others in the same region aren't affected. It's brilliant. So why do we care about all this? It really boils down to one word: resilience. See, by building your application to run across a couple of different zones within a region, you're protecting yourself. If a single data center has a bad day, a power outage, a network issue, your app doesn't just die. Nope, it keeps on running from another zone. This is absolutely fundamental to building apps that your users can depend on. So we've got the physical foundation port. The next layer we need to build is the compute layer. This is the engine, the brains of your whole application. And right away, you face your first huge choice. How much of the underlying machine do you want to manage yourself versus how much do you just want to hand off to Google to worry about? Your first option is what we call infrastructure as a service, or IaaS for short. In the GCP world, this is compute engine. The best way to think about it is like you're leasing a raw piece of land. You get a blank slate virtual server, and you can build literally whatever you want on it. You choose the operating system, you install all the software, you have total granular control. The catch? You're also responsible for all the maintenance, security patches, updates, the whole shebang. Now, the other side of the coin is platform as a service, or PaaS. In GCP, this is called App Engine. And if Compute Engine is leasing land, App Engine is like renting a fully furnished luxury apartment. You don't worry about the plumbing, the electricity, or fixing the roof. You just move in and focus on your thing, which in this case is just writing the code for your app. Google handles everything else: the servers, the scaling, all of it. This table just nails the difference, doesn't it? It all boils down to a classic trade-off. Do you need control or do you need speed? If you need total control for a super custom setup, or you're just moving an old app to the cloud without changing it, Compute Engine is your go-to. But if you want to build a scalable web app and get it launched fast, App Engine is all about convenience and velocity. Awesome, so you've picked your engine. But an engine is kind of useless without fuel. And in our world, that fuel is data. Every useful application needs to store stuff. GCP knows this, so instead of a one-size-fits-all solution, it gives you this amazing, specialized toolbox with exactly the right tool for the right data job. Let's pop open that toolbox. You've basically got three main tools for three different jobs. First, for just raw files, images, videos, backups, what we call objects, you use cloud storage. It's simple and massively scalable. Then, for your classic web application with structured data that fits nicely in tables, you'll reach for Cloud SQL. And finally, for huge modern apps with flexible data that doesn't fit a rigid structure, what we call NoSQL, you've got Cloud Datastore. Okay, so we've got a place to run our code and a place to store our data, but the real power, the real magic of a platform like GCP comes from all the services that connect everything together and let you scale to incredible heights. This is where you get to use the same tough, battle-tested infrastructure that Google itself uses to run its global empire. It all comes back to this simple philosophy: build, store, and analyze. Google just gives you all these powerful building blocks so you can tap into the same infrastructure that keeps YouTube and Google search online. You're not just renting servers anymore, you're plugging into a global supercomputer. Think of these services as cheat codes for development. They stop you from having to reinvent the wheel over and over. I mean, instead of trying to build a data warehouse that can handle petabytes of data yourself, you just use BigQuery. Instead of coding a complex system to manage how other services talk to your app, you use Cloud Endpoints. It lets you focus on what makes your idea special, not on all the boring plumbing. This elasticity is just one of the most incredible parts of the cloud. Imagine your app goes viral. It gets featured somewhere huge, and your traffic goes from 100 users an hour to 100,000. On an old school server, you just crash and burn. On GCP, the platform sees that spike and automatically spins up more resources to handle the load, usually before you even notice there's a problem. And here's the other half of that magic trick. Just as importantly, when the traffic spike is over and things calm down, the platform automatically scales everything back down. You don't get stuck paying for a bunch of servers you're not even using. That's the whole heart of the pay-as-you-go model, and it's what makes the cloud so incredibly cost-effective. So there you have it. We've gone through the whole architectural blueprint, from the physical network all the way up to compute, storage, and scaling. Now let's stop talking theory and see how these concepts actually translate into real-world tasks that you would do every day. To make this super concrete, we're going to look at two perfect examples. First, we'll see how to use cloud storage to host a simple website. This shows how you can serve content to the entire world without managing a single server. Then we'll level up and use App Engine to deploy a dynamic web application, which really shows off the power of PaaS to get your code live in just minutes. And that brings us right back to the fundamental choice, not just on GCP, but on any cloud platform. It's that constant trade-off between control and speed. So the question to leave you with for your next project isn't just, what should I build? It's, how should I build it? Do you need the raw power and total control of IaaS, or the incredible speed and simplicity of PaaS? The right answer? Well, that depends entirely on what you're trying to do.